This afternoon, I have the pleasure of introducing Mark Zuckerberg, which is one of our guest speakers this semester, to come and talk a little bit about computer science in the real world. As most of you probably know, as you guys are all do this much more than I do, founder of Facebook.com, which is a social networking program, whatever you want to call it, used at over 2,000 schools across the nation and possibly the world. Is it the world too, or just the nation? Okay. So good influence for doing some things in computer science. He's going to tell us some of the background of it and what's been important and so forth. So please join me in welcoming.
Yo. All right, cool. This is the first time I ever have had to hold one of these things, so I'm just going to attach it really quickly. 1 second. Can you hear? Is this good? Is this amplified at all? All right, sweet. So, this is like one of the first times I've been to a lecture at Harvard. So I guess like what's probably going to be most useful for you guys if I just take you through some of the courses that I took at Harvard, where I actually did go to lecture sometimes. I was joking, and sort of like how different decisions that I had to make when I was moving along with Facebook got impacted by different stuff that I was learning in the classes that I was taking. And if all goes according to plan, then maybe some of you guys will come out of this thinking that taking CS or engineering stuff at Harvard is actually sort of useful. So that's the game plan. I think that this is slotted for 2 hours. There's no way I'm going to speak for 2 hours. I'll probably speak for like 20 minutes or 15 minutes, and then I'll just let you guys ask questions, because I'm sure you guys have more interesting stuff to ask me than I can come up with to talk about myself. So, okay. So I guess I'll just kind of get started. When I was here, I started off taking 121. I never actually took 50, so I'm probably, you should have gotten the other guy who was doing Facebook, Dustin Moskovitz, who is my roommate. When we got started, the site was written in PHP, which isn't something that you learn in one of these classes, but fortunately, if you have a good background in C, the syntax is very similar, and you can pick it up in like a day or two. So I started writing the site and launched it at Harvard in February 2004, so I guess almost 2 years ago now. And within a couple of weeks, a few thousand people had signed up, and we started getting some emails from people at other colleges asking for us to launch it at their schools. And I was taking 161 at the time, so I don't know if you guys know like the reputation of that course, but it was kind of heavy. It was a really fun course, but it didn't leave me with much time to do anything else with Facebook. So my roommate Dustin, who I guess had just finished CS50, was like, hey, I want to help out. I want to do the expansion and help you figure out how to do the stuff. So I was like, that's pretty cool, dude, but you don't really know any PHP or anything like that. So that weekend he went home, bought the book Perl for Dummies, came back and was like, all right, I'm ready to go. I was like, dude, the site's written in PHP, not Perl, but that's cool. So he picked up PHP over like a few days, because I promised that if you have a good background in C, like PHP is a very simple thing to pick up. And he just kind of went to work. So the first big decision that we really had to make was in how to kind of expand the architecture to go from the single school type setup that we had when it was just at Harvard to something that supported multiple schools. So this was a decision that kind of had to be made on a bunch of levels, both like in the product and how we wanted privacy to work. But I think that one really important decision that's helped us scale pretty well is how we decided to distribute the data. So I don't know how much of like kind of complexity stuff and like big O notation you guys do in this class. Okay. So one of the most complicated computations that we do on the site is the computation to tell how you're connected to people, right? Because if you can imagine that's stored as sort of a series of I guess undirected, it's not weighted, so undirected, unweighted pairs of ID numbers of people in the database. Then if you want to figure out who's friends with someone, you have to look at all their friends, right? So that's maybe like 100 or 200 people. But then if you want to figure out like who's a friend of a friend or what the closest connection is there, then you kind of have to look at the 100 or 200 friends of each of those friends. So it becomes, at each level, there's another factor of n multiplied in, where n is the number of friends that each of your friends has. So you can see that this kind of becomes exponentially difficult to solve for the shortest path between people. So I mean, if you're just looking for a friend of a friend, that's n squared. If you're looking for a friend of a friend of a friend, that's n cubed. And I mean, that's something that traditionally was pretty difficult for a lot of the predecessor sites to Facebook. So, and for example, Friendster had large problems with this because they were trying to compute paths 6 degrees out or like 7 degrees out. And I mean, that's something that when you're doing like n7th, like that just is really, I guess, very hard, and took down their site for a while. So I mean, one of the things that we kind of had in mind when we were figuring out how to do this was how do you distribute the database in such a way that this computation becomes manageable. So what we decided was that everyone on the site does most of their activity at the school that they're kind of based at. So if you're at Harvard, then like most of the people who you're going to be seeing or transacting with on the site are going to be at Harvard. It's actually probably like 90% of the stuff that you do on the site. So we decided to split up the databases and create one instance of a MySQL database for each school on the network. And in doing that, I mean, if you notice, the paths that we compute are only within the school. So instead of, say, like now we're at 6 million users, and instead of having to do n cubed over some portion of 6 million, it's just n cubed over 10,000, which is a much more manageable, I guess, type of computation. So that was sort of the first like big architectural decision that we had to make that contributed to us not dying a few months later. And I don't know, it was probably like a pretty important one. So I mean, when we first set up the site, we had just one computer that we were running. It wasn't in our dorm room, we were renting it. I kind of learned my lesson for trying to run a computer, run a site out of my dorm room a few months earlier, and Harvard almost tried to kick me out. So so I ended up renting a server off-site this time, and I guess like running originally the database and the web server, so Apache is what we were using in this instance, to serve the pages from the same machine. And because we distributed the databases in the way that we did, we were able to, as time went on, just add more machines linearly and sort of just grow the site without having any kind of exponential expansion on the amount of machinery that we had. But after we hit, say, about like 30 or 50 schools, we started realizing that we could start getting more performance out of MySQL or Apache. And that like some of the way that stuff was set up just like wasn't as optimal as it could be. So I mean, for example, when you have MySQL machines and Apache machines on the same, like MySQL and Apache running on the same server, then if something happens to that server, then not only does the database for that school or the schools on that server just stop kind of responding in a way that is like, that will get you anything useful, but you can't even load any web pages, so you get page not found. And that kind of sucks. But another issue is that the variance and the use from school to school is also not going to be perfect. So I mean, some schools are always going to be kind of have heavier use. I mean, we have schools now like Penn State that have 50,000 users, and then the majority of the schools I think still have less than 2,000 users. Just because there's a lot of small schools and a lot of schools that don't have complete ubiquity. So so I mean, in trying to deal with this issue and like kind of make it so that you could deal with the fact that Penn State had 50,000 people and just a ton of users all the time, and then you have some schools that don't, what we decided to do is separate out some of the web servers from the database servers and make it so that you could, so that we just had a pool of Apache web servers that we could load balance between and make it so that you can use those uniformly while just having the database layer be sort of consistent. So I don't know if this stuff is interesting to you guys at all, or I mean, if this is anything that that matters to what you guys are studying now. I mean, so if there's more stuff that you guys would rather know about in terms of the architecture, then I'll kind of leave that open to questions later. So I'm just that I don't spend a lot of time just talking about random applications that you guys might not ever care to use. But let me try to find some interesting examples. So I mean, so I guess one of the things that was pretty interesting was just sort of trying to, like, when we got to a point in terms of traffic where we started maxing out the performance of some of these open source applications that are generally pretty performant. So for example, MySQL is a really good open source database. Right? And I don't know if any of you guys sort of in your own time mess around and like make anything with MySQL or have used it in any way. But like, I mean, it's pretty easy to use, and it's also like decently quick. You know, indices work pretty well. It's not as fully featured as something like Oracle, but it's pretty good. And I mean, we got to a point where I think around when we started doing like maybe 100 million page views a day, that that we started running into some bottlenecks on that. So like, so for example, a typical query on MySQL might take like 2 to 4 milliseconds. And I mean, that's not that much, but like when you're doing 100 million of page views a day and each page view might have like 30 to 50 queries, I mean, especially if you're doing something like a profile view that just kind of queries all kinds of different information, then that kind of starts to suck. So we started to develop a caching sort of layer that kind of allowed quicker access to some of the information. And originally we were using another open source application, Memcache, which I don't know if any of you guys have any experience with that. But like, it was pretty quick. It got access times down to like, I guess like 0.3 to 0.5 milliseconds, which is pretty good. But it also like has a bunch of sort of distribution issues. And I mean, it's supposed to be like a distributed hash table sort of application where it's like, you can just attach like any number of Memcache boxes in a cluster and be able to just like hook it up and have it go. But we sort of ran into a lot of issues there where like different Memcache boxes would go down and there was no redundancy on the information. So like when a Memcache box went down and you had a cache miss, then all of a sudden like you had a lot more traffic going to like a specific set of databases, and that would suck. So so as time went on, we even kind of like outgrew Memcache and sort of the indices on MySQL. And I mean, we still use that stuff, but we had to build on top of that extra redundancy. And I mean, I think that like, that's something that's probably like maybe a little interesting, but I mean, I'll let you guys ask me more questions about that later. I'm like not really sure what would be interesting to talk about right now. Maybe you guys could help out a little. Go for it.
Well, I'm curious about sort of maybe not on the coding side, but just as an entrepreneur going into an online business like this, how do you felt the atmosphere was with big players already in the market and other big players who you thought might be able to come into the market, for what your experience was with that, maybe like on a technical side,
Mm-hmm.
sort of ramp up and technically how you see this business?
Yeah, so I mean, I think that like, so that's not a technical question at all, but like, I don't know, I mean, so I guess I'll just like go into question time now, because like, I'm not really sure what's like relevant stuff for me to be discussing. So I'll just answer this, and then anyone else who wants to ask me questions can just go for that. I mean, I guess like I never really spent a lot of time worrying about stuff like, I mean, there are companies out there like Google that could just sort of get into your space and do whatever you want at any time. And I mean, I think that like one of the cool things about like this time in technology is that individuals are leveraged and able to do way more than they'd really ever been able to do before. You know, and like even like 4 years ago when Google was started, I mean, now they have hundreds of thousands of machines, you know, and probably billions of dollars spent on equipment. I think like the generation before Google, you couldn't even make a site without sort of like some big piece of hardware. And I think like eBay, for example, ran off of 2 like $50,000 machines or something. And like, it's like you just can't start doing that if you're just a kid in a dorm room, you know? So I think that like the fact that we could sort of rent machines for, you know, like $100 a month and use that to scale up to a point where we had 300,000 users is pretty cool, and it's a pretty unique thing that like that's going on in technology right now. And I mean, it like makes it so that instead of worrying about just like who's sort of the big player and like what is Google going to do next, you can do more of like, you could just like get a lot of stuff done. And I mean, instead of like having to go out and have some of the traditional business problems, like you have to raise capital before you can make anything, like that's no longer an issue. So you can just like, you're leveraged to do a lot more on your own now. I don't know if that kind of answers the question that you're asking, but I mean, it's one of the reasons why I think that at this point it makes a lot of sense to be studying this stuff, because like at no point in the past could you leverage like such a small amount of money to get powerful enough technology to really touch people in the way that you can today. So I mean, Google does about 250 million page views a day, right? They have hundreds of thousands of machines and like 5,000 employees. Facebook does 400 million page views a day, so that's like almost, that's like a lot more than Google does, and we have hundreds of machines and we just passed 50 employees. So like, and that's just like a sort of a technical generation of 3 or 4 years in the architectures that were created. So I mean, and then you go like 3 or 4 years back before that from like eBay to Google, and it's just completely different, because I mean, at least Google was running off of this, like a lot of distributed equipment that, I mean, they have hundreds of thousands of machines, but the idea there was get a lot of shitty machines, that are like really cheap. And I mean, that's a big step up, because then it's like, okay, that's more redundant, I mean, they're not losing information, they don't expect stuff to always work. It's a much more kind of mature attitude than eBay's, which, I mean, was the only thing that they could do at the time, but yeah. So.
I have a question about the DHT stuff.
The what?
The distributed hash table stuff.
Yeah, well, which one?
I was just wondering if you've have you released at all your extensions to Memcache? Because one thing I've noticed is that there aren't really good available libraries for DHT stuff. There's all this wonderful research, but in terms of implementations that actually deal with all the redundancy issues and all those things.
Yeah. A lot of the stuff that we didn't necessarily extend Memcache, we like built a bunch of stuff like ourselves. So I mean, right now it's not open source. I mean, we consider doing it, and I mean, there's a lot of work that goes into making stuff open source, which, I mean, it's like on top of whether or not you want to like lose the competitive advantage. It's just like, it's kind of unfortunate, because I mean, I think that if it were just easier to make something like that, then you could do it. Like you could just like release the code, but like then there's a lot of support, and like licensing and all that stuff, and I don't know. We found that it's been kind of annoying. I mean, one of the things that we actually considered making open source was this search server that actually that guy sitting right there made while he was still out in California. And I guess like we got to a point where MySQL was lagging a little on some of the searches that we were trying to do, and we decided that it would be a cool thing to do to just like make sort of a series of like distributed machines that could kind of, he doesn't use a hash table. What's the structure that you use, McCollum? So I mean, yeah, we thought about making that open, but then like that's when we kind of like had to do all this work to like come up with a license, and we're just like, all right, screw that. But yo.
What do you spend most of your work time doing these days?
Hiring people. I guess like as you grow, like the most important thing is to have smart people, right? I mean, and if you think about how, like the technical leverage stuff that I was just talking about and answering that guy's question, like as technology becomes sort of more generic and less expensive, the leverage point becomes more in the people. So I mean, if you kind of think about this from a perspective of like a person to people time spent, or like user time spent, or page view analysis, it's like because of technology now, like people are much more leveraged to kind of do and to do more things and just be more important in the equation. So because of that, it's like really important to get the most intelligent people. And also, I mean, it's like when you're a small company, then you can be really nimble and get a lot of stuff done, and there's relatively little bureaucracy. So if you have smart people who can take advantage of that to build cool things, then that's awesome. I mean, I guess besides that, I don't know, designing new things. There's not much corporate bureaucracy yet, so I don't have to waste that much time on that. Keep on going. Yeah.
How much have you like spoken, consulted with lawyers so far?
I have a lawyer who works for me full time.
Okay.
Yeah.
Is it like a big part of like running a business? Like, would you recommend working on lawyers early on?
We didn't, and that, I guess, provided some annoyance later on. I guess like getting stuff set up really well is good, right? I mean, it's like getting stuff clean is really good, and I mean, no one's ever going to tell you like, oh, like a lawyer's bad. It's all just like a question of opportunity cost and what you prioritize, right? And like I guess that in our case, it's like we now have to deal with like a bunch of stuff that wasn't set up properly in the beginning, but like, I mean, actually most of that stuff is dealt with, so I mean, it's not even a big deal anymore. But like, but instead of talking to lawyers early on, we were making stuff, you know, and like I think that was probably the right use of our time. So it's like, I mean, I think that one cool characteristic of a lot of the companies that end up being really successful, not that we are really successful, but I guess we also fall into this bucket, is that they started off as someone trying to make something cool and not someone trying to make a company. You know, and like, I mean, you kind of have, like Google came out of Larry and Sergey's like PhD dissertation at Stanford, and Yahoo came out of just like, I guess, also some Stanford guys just like kind of screwing around in their dorm room, and eBay came out of like some guy trying to build a marketplace for his girlfriend to exchange Pez dispensers. You know, Amazon was a little more calculated, but I mean, so I can't imagine that any of those people really had that much advice, and it seems to have worked out okay for them. But I mean, at the same time, I'm not going to kind of sit here and tell you not to get advice on stuff. And a lot of times, people are just like too careful, too. I mean, it's like, I think it's more useful to like make things happen and then like apologize later than it is to make sure that you dot all your I's now and then like just not get stuff done. Yeah. Go for it.
When do you think that Facebook will reach a point where it could become that sort of big company that should be unseated by a new idea, and maybe becomes less agile in getting on the trend rate? Do you think people will reach that point anytime soon? How we keep it from?
Well, I mean, I think that you're kind of always at that point, right? I mean, most companies are started on like a couple of ideas, and those are like a few things that they do